Students, today I am going to explain to you why in McCapital graphical method to find out the number of stages for binary separation of components using distillation method, XD and XW points are located on y equal to x line. Now in McCapital method, we construct the mole fraction diagram. This is y-axis, this is x-axis, the scale is from 0 to 1, 0 to 1, and after that we draw the diagonal, which is nothing but y equal to x line. It is also known as 45-degree line. And after that we usually construct the equilibrium line, considering an ideal solution basically, and then after that we locate XD point, which is nothing but the distillate percentage purity in the top product, the feed composition, and XW, which corresponds to the bottom product composition. Here I must mention that XD, XF and XW all are with respect to the lighter component or more volatile component, okay? Because it is a binary solution, so once the mole fraction for the lighter components are given, you just subtract it from 1 and you will get for the heavier component, okay? After that, probably you have noticed that we construct the enriching section operating line, and the enriching section operating line is usually constructed from the y equal to x line, okay? And depending on the value of reflux ratio, which is R, okay, the value of reflux ratio, we can easily find out the slope of the enriching section operating line. Also we can find out the intercept, which is nothing but XD over R plus 1, okay? So if you know the value of the reflux ratio, if you know the value of XD, you can find out the y-axis intercept. So this is basically the intercept, and from this point you join it and construct the enriching section operating line, which is EOL. And then depending on the feed condition, we construct the feed line, okay? So considering it at the feed is at its boiling point, it will be a vertical line, and then you find out the point of intersection between feed line and enriching section operating line. And then from this point, okay, XW point is located on y equal to x line, and then you join these two points to find out the stripping section operating line, or SOL, okay? But the most important question is why the XD point or the starting of the enriching section operating line originates from y equal to x line and XW originates on y equal to x line, okay? That's very important and pertinent. Now to find out that, we have to look into the equation. Now the enriching section operating line equation is nothing but yn plus 1 is equal to r over r plus 1 xn plus xd over r plus 1, okay? So xd over r plus 1 is basically the intercept, fine. Now now this basically the subscript n and n plus 1, they correspond to the stage number or the plate number within the distillation column, okay? Now if the value of x at the top of the distillation column, okay, if xn here is equal to xd, so in that case the equation becomes yn plus 1 is equal to r over r plus 1, xn becomes xd plus xd over r plus 1. You take xd over r plus 1 as common factor, so it is going to be r plus 1. So r plus 1 cancels out, so we are going to get the value of yn plus 1 is xd. So if the value of xn is xd, the corresponding value of y is also xd, okay? And that is the reason why corresponding to xd point on the x-axis, the point in the y-axis, which is yn plus 1, happens to be xd itself, okay? And that is the reason why the point originates on y equal to x line. Okay. Similarly, for the stripping section, if we consider stripping section operating line, which is ym plus 1 is equal to lm over vm plus 1 xw minus w over vm plus 1 xw. Sorry, I made a mistake. This is not xw, rather it is xm. Okay. So basically m or m plus 1 stands for the plate number or the stage number. Okay. Now if xm is equal to xw, so in that case ym plus 1 becomes equal to lm over vm plus 1 xw minus w over vm plus 1 xw. Okay. Now you take xw over vm plus 1 as a common factor, so it is going to be lm minus w. Okay. Now what is lm minus w? Now to understand lm minus w, so you have to understand, suppose this is the stripping section of the distillation column. So basically feed enters somewhere over here, and suppose this is the mth plate, this is the m plus 1th plate, this is the n capital nth plate, the last plate of the distillation column. The bottom product comes out of it, goes into the reboiler. So this is basically W. The vapor rising from the reboiler is going inside the distillation column. Okay. So if you do the material balance across this envelope, okay, across this envelope, if you do the material balance, so the liquid stream which is coming out from M plate is basically Lm. The vapor which is rising from M plus 1th plate is Vm plus 1. So with respect to this envelope, okay, if you do the material balance, overall material balance, so Lm stream is entering is equal to what is leaving? W is leaving, Vm plus 1 is leaving. So W plus Vm plus 1. Okay. So Lm minus W is nothing but Vm plus 1. So this Lm minus W is nothing but Vm plus 1. So if that is so, so Lm minus W becomes Vm plus 1. And this Vm plus 1 cancels out. So the value comes xw. So corresponding to xw point on the x-axis, the y-axis value ym plus 1 happens to be xw only. And that is the reason why in McCabe-Thiele diagram, to be precise, the mole fraction diagram, when you construct all the lines, y-axis, x-axis, 0 to 1, so y equal to x line, the diagonal, the equilibrium line, the EL. Okay, so corresponding to xw point, corresponding to xd point, the y coordinate happens to be xd itself. Okay, we have already seen it is xd comma xd, and that's why it will start from y equal to x line. Similarly, for the xw case, on the x-axis, the corresponding y-axis value happens to be xw itself, and that's why it originates on the y equal to x line. This explains all the technicalities. However, there is another way to look into it, is that normally with respect to the enriching section, if we just consider, okay, this is the top plate, suppose plate number 1, vapor is rising from the top plate, okay, and the vapor is going into a condenser. The condenser, basically, if it is a total condenser, then all the vapor will be liquefied into liquid, and the part will be taken out as a top product, distillate, corresponding composition is xd, and part will be sent back inside the tower as a reflux. Okay, its composition is also xd. Okay, and this is the vapor v1, and corresponding composition is y1. Now if the condenser happens to be a total condenser, then all the vapor will be condensed into the liquid. So in that case, Y1 composition, vapor composition is going to be equal to exactly the liquid composition XD. So in that sense, the top, because the this enriching section operating line starts from the top of the tower. So if it is a total condenser, so corresponding to the point, the top coordinate will be XD comma Y1. And since Y1 is equal to XD, in case of a total condenser, the point corresponding to the enriching section operating line will also start from Y equal to X line. But if the condenser is a partial condenser, then Y won't be equal to X, rather Y is going to be a function of X. So in that case, we cannot basically say that. Okay, so overall, from the material balance equation, you can just find out the logic behind why the XD and XW points are located on Y equal to X line when you construct the stages in McCabe-Thiele method. Thank you.